Hi, good morning. Welcome to PHY 314 Numerical Computation class. I am Dr. Agbaoye Ridwan Olamide. I will be the facilitator for this class to guide you through how to navigate the course material and how to understand the concepts within this course and be able to solve problems in this course. So join me as I introduce you to PHY 314 Numerical Computations. This course is a 3-unit course and the title is Numerical Computations, and it is subdivided into 7 units. In each of these units, we'll look at different concepts and solve different problems. Then we would have a TMA for every week where you get an assignment and you'll be able to solve problems, and we'll discuss it in our online session. We'll look at the concepts, look at the solutions to the assignments, and with that I believe we'll be able to learn a lot. So in unit 1, we'll be looking at approximations and errors in numerical computations. There we'll be discussing accuracy of numbers, accuracy in measurement. Of course, a lot of this you must have learned before now, but would want to refresh your memory such that you are able to understand how to round up errors, how to look at inherent errors, how to truncate, and how to see the truncation errors. We'll look at absolute errors, relative errors, percentage errors, amongst others. Then we would have the summary and the total marked assignments that you go home with. You learn how to solve problems within the frame of what we've taught. Then we'll continue with approximations in unit 2, where we'll look at approximations and errors in numerical computations again. But in this case, we'll be looking at linear graphs. We'll be looking at linearizations, how to do curve fitting, how to use the method of least square, and how to use the method of group averages. So that would take care of in unit 2, and would also have a summary and a total marked assignment. So in our total marked assignment, once again, you have the time to solve real problems on your own, and if you have issues with any of the problems, we can discuss it in our online session. Then in unit 3, we'll be looking at linear systems of equation, how to solve system of equations using different methods, and such methods include Gaussian elimination. We'll be looking at Gauss-Jordan elimination. We'll be looking at Jacobi iteration, and a host of others like the Gauss-Seidel iterations and so on. Then similarly, you would get your total marked assignments, you solve problems, then we'll discuss the solutions of this problem in our online session. Then we can quickly move to unit 4, and unit 4 will be interested in looking at root of algebraic and transcendental equations. Of course, before now look at we know how to calculate root of algebraic equation, and with that we'll be looking at different methods aside from what we've known before, aside from the normal completing the square methods, almighty formula like we used to say then. So we'll be looking at the bisection method and its merits and demerits. We'll be looking at Newton-Raphson method. We'll look at the advantages and its disadvantages. Then we'll look at seconds method, we'll look at regular Fauci methods. A host of these methods are what we'll check, solve problems with, and see how it relates to numerical computations. Before we'll proceed to our usual total marked assignments, and with that we'll conclude unit 4, and that takes us to the next unit, which is unit 5. In unit 5, we'll be interested in finite differences and interpolation. There we'll be looking at forward differences and errors in finite difference table. We'll look at Newton's forward interpolation formula. We'll also be looking at the Newton backward interpolation formula. So all of these methods in finite differences and interpolations are what we will take care of in unit 5. And of course, we would end our unit 5 with our total marked assignments. Problems will be solved, and we'll discuss the problems in the online Zoom session. Then we'll briefly we'll quickly look at Unit 6, where we'll look at numerical integration. And we'll look at several methods, which include the trapezoidal rule, the Simpson 1/3 rule, the Simpson 3/8 rule. We'll look at Newton's quadrature formula, the errors associated with it, errors in trapezoidal rule, errors in Newton 1/3 rule, and the Romberg method. So all of these methods are the interesting numerical integration methods that we'll be looking at, and therefore problems will be solved in terms of tutor math assignments, and discussions will be made with respect to all of these methods. Then that takes us to our Unit 7. In Unit 7, we are interested in initial value problem of ordinary differential equation. And here we'll be looking at different methods of solving first order ordinary differential equation. We'll be looking at the Picard method, the Euler method, the modified Euler method, and the very popular Runge-Kutta method. We'll look at different orders of Runge-Kutta method, and most importantly, we'll look at the fourth order Runge-Kutta scheme for a system of 3 equations. Of course, we'll learn how to reduce higher order differential equation into first order differential equation. So a lot of these differential equations are what we would look at in Unit 7, and that rounds up the entire 7 units in this course. This is going to be engaging. It could be a little bit tedious, but trust me, it's going to be engaging. You need a little knowledge of mathematics, you need a little knowledge of computation, and a little knowledge of physics. So together we'll be able to infuse these 3 knowledge together and use it to master computations. So the objective of this course as follows. Number 1, we would like you to understand the various types of error and how to minimize them. Of course, in every day of our life, or in every calculations we do, we have various types of error. And if we learn how to minimize them, then we would do a lot of calculations or a lot of real life activities with little error. And that is the goal of our day-to-day activities: minimize error, maximize efficiency. Then also we'll learn how to linearize a given expression and look at the relationship between variables and look at the relationship between constants and variables. Also, we'll do our usual curve fitting for a given set of data. There are several methods of doing curve fitting. We'll look at a lot of them, and at the end of the day, we would understand how to fit curve better. Then we would also write a C++ program for solving numerical problems. A lot of numerical problems can be solved by hand, while a lot of them are too bogus to be solved by hand. Of course, you cannot solve every problem by hand. The best way to solve problem is to use program to iterate over problems and solve as many problems as possible within the short period of time. So here, the programming language you'll be interested in is a C++, and we'll use that to solve problems. So amongst the objective is also to solve a system of linear equations. We have listed the methods to be used to solve these equations, and that is one of the objectives. Another objective is to look at the roots of a given algebraic or transcendental equation. Then also you'll be able to obtain the definite integral of a given function of single variable. Of course, you'll also be able to work with finite difference scheme, and you'll be able to solve the first order initial value problems of the ordinary differential equation. Also, you'll be able to resolve higher order initial value problem or higher order ordinary differential equation into a first order in ordinary differential equation. And lastly, you'll be able to solve higher order initial value problem of ordinary differential equation. This assessment, this facilitation has 2 basic assessments. The first assessment is a popular tutor math assignment that I have been mentioning over time. For every unit or for every class we have like this, we would always have tutor marked assignments, which constitute 30% of your entire grade for this course. At least you have 4 tutor marked assignments, and you must be able to attempt 3 of them before you'll be allowed to sit for this examination. So without 3 out of 4 TME submitted, then you may not be given the opportunity to write the exam. And at the end of the day, you would participate in an examination that constitutes 70% of the whole course, of the mark assigned to the whole course. With that, you have 100% of the entire course. And the time for the exam will, of course, be communicated to you beforehand, so that you have time to prepare for your exam. This facilitation entails a weekly lesson video, just like we are doing, which allows us to pick several aspects of the units, discuss them just like we are doing, and it will be sent to your e-learning platform. You'll go through it, note your questions, note the difficulties you have, and at the end of the week, we would have a 1-hour live session where we would clarify concepts, would give answers to your questions, and also we'll see how to solve practical problems. So the basic reason we are having the online session is to interact with ourselves, not to teach per se, but to interact. We interact, clarify concepts, you ask questions, I give answers to the questions, and we solve practical problems. Basically, that is what we'll do in our 1-hour live session. And at several intervals, I'll be giving quizzes where you submit, and would have a discussion forum. In a discussion forum also, we discuss concepts, clarify issues, and be able to understand the course better. For ease of communication, we would create a WhatsApp group that would allow us communicate effectively in due time. The students are expected to create a WhatsApp group, add the facilitator. They will be able to send announcements and send important messages to ourselves. Also, we would use the email communication channel to distribute information to members of this class, and with that, we would know when we are to submit our next assignment, know where we are to hold our discussion forum, and so on. So basically, this is a summary of our course facilitation, and I believe you would love to be in class, and I would also be waiting to have you around. Numerical computation is the fundamental of every computational scientist. You must be able to handle computation. You must be able to write a little bit of program to automate your computations, and you must be able to, at the end of the day, use several programs to solve different problems. What we are interested in a computation class, or as a computational scientist, is to solve problems, irrespective of the kind of problems you have. Basically, these are the kind of problem you don't want to go to the laboratory for. There are problems you can conceptualize and solve on your computer. Now, at the end of the day, you give experimentalists a feel of what they expect in the lab, and a feel of the kind of challenges they will face while solving their problem practically. So it's lovely to be around here. I hope to see you in class. Thank you for joining us.